Hello everyone. In the previous video, we saw an introduction to matrices, order of the matrix, and an example related to these topics. If you want to quickly grasp concepts through questions, you can check out these videos. I will leave the link in the description. In this video, we will learn about different types of matrices. So the first type of matrix we will discuss is row matrix. If any matrix has only one row, then that matrix is a row matrix. Now this is matrix A, and the order of the matrix will be 1 by 4 because it has one row and four columns. Since the matrix has only one row, the matrix is a row matrix. Next is a column matrix. If a matrix has only one column, then the matrix is called column matrix. Now this is matrix B, has three rows and one column. Therefore, the order of the matrix is 3 by 1. Since the matrix has only one column, this matrix is a column matrix. Next is a square matrix. If in a matrix number of rows is equals to number of column, then that matrix is called square matrix. In general, order of the matrix is m by n. M is the number of rows and n is the number of columns. For square matrix, m equals to n. That is, number of rows is equals to number of columns. In the given matrix, you can clearly see that the number of rows is equals to 3 and the number of columns is equals to 3. Therefore, number of rows is equals to number of columns, which means it is a square matrix. So, order of the matrix is 3 by 3, or we can say square matrix of order 3. Any of the way can be used to represent order. In general, we use this notation to represent any matrix. In bracket, we write Aij. Aij represents every element in the matrix, lying in the ith row and jth column. M cross n in the subscript represents order of the matrix. M means number of rows and n means number of columns. But for square matrix, number of rows equals to number of columns. That is, m equals to n. So in general, we can write capital A equals to Aij in subscript m cross m. Now we will understand what is diagonal elements. Diagonal elements exist only for square matrix. The element A11, A22, A33 goes on up to AMM, collectively called diagonal elements, and the remaining elements are non-diagonal elements. Let's understand for the matrix of order 3 by 3. This is the general square matrix of order 3. You can see A11, A22, A33 form a diagonal. Therefore, these elements are called diagonal elements, and all the other elements are called non-diagonal elements. You may have a confusion for which you may consider these elements as diagonal elements. So let me clarify that the square matrix has only one set of diagonal elements. In our case, these set of elements are the diagonal elements. We will move on to the next type of matrix, diagonal matrix. Diagonal matrix are also a square matrix. But in a diagonal matrix, all the non-diagonal elements are 0. Means elements other than A11, A22, A33 up to AMM are 0. This is the general form of diagonal matrix of order 3. So this is the example of a diagonal matrix. You can note that all the non-diagonal elements are 0 and it is a square matrix of order 3. So this is another example for diagonal matrix, which is a square matrix of order 2. You can see elements other than the diagonal elements are 0. Therefore, this is a diagonal matrix. Next type of matrix is a scalar matrix. Scalar matrix is a diagonal matrix in which all the diagonal elements are equal or same. These are the example of scalar matrix. Matrix A is a scalar matrix of order 3. Matrix B is a scalar matrix of order 2, in which diagonal elements are equal and non-diagonal elements are 0. Next type of matrix is a identity matrix. Identity matrix is a type of scalar matrix in which all the diagonal elements are 1 and non-diagonal elements are 0. And we represent the identity matrix using capital letter I subscript n. The n in the subscript represents order of the identity matrix. So these are the example of identity matrix of different orders. First is the identity matrix of order 1. We represent it by I subscript n. Second is the identity matrix of order 2. We represent it by I subscript 2. And the third is the identity matrix of order 3. We represent it by I subscript 3. Next type of matrix is a zero matrix. Whenever in a matrix all the elements are 0, then that matrix is called zero matrix. Zero matrix can be a square matrix or non-square matrix. We denote the zero matrix using capital letter O. These are some examples of zero matrix. You can note that Sum zero matrix are square matrix and sum zero matrix are non-square matrix. Now we will move on to the next topic, equality of matrices. Two matrices are said to be equal if their orders are same and corresponding elements of both the matrices are equal. For example, you can compare the order and elements of matrix A and matrix B. On comparing, you can note that order of matrix A and B is 2 by 2 and their corresponding elements are also equal, which means first element of matrix A and B are same. Similarly, you can check the other elements which is same in our case. Therefore, matrix A and matrix B are equal matrices. Now let's compare these matrices. On comparing, you can note that matrix C and matrix D is of same order, which is 2 by 2. But corresponding elements are not equal. The element present in first row, second column, and element present in second row, second column are not equal. Therefore, matrix C and D are not equal matrices. This is how you compare the equality of matrices. In the next video, we will understand operation on matrices. So, subscribe and stay tuned for more videos. Thank you for watching the video.